Good morning, grade 7s. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all really well today and looking forward to today's lesson. Just a reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to use it to send me any feedback, questions, queries, topics that you'd like me to go over again, or perhaps a topic I haven't taught that you'd like me to cover, and I'd be happy to do so moving forward. Today's lesson is looking at ratio, and then on either side of that we've got our warm-ups, mental arithmetic questions covering past taught principles, and then our brain benders and finishes to end off on. So today's warm-up is a fraction theme, and you need to tell me the value of each symbol and then the blue question mark at the end. Take your time, work through it methodically. Write down your thoughts and your processes so it makes a lot more sense to you. Check your work and then press play to see how you guys get on. So I'm going to start on the third line, and I'm going to use the fact that a quarter plus a quarter is equal to a half. So remember, the denominators are the same, so therefore we can add the numerators. And a quarter plus a quarter is 2 quarters, okay? But 2 quarters is the same as 1/2. So that means for my second line, 1 subtract 3 quarters must be equal to 1 quarter, okay? I know that from the fourth line over here, 3 is going to be equal to 3, okay? So then if I go to the top line, I already know that 3 quarters plus 2 quarters, because the denominators are the same in the picture, plus 3 quarters is going to be equal to 2. Okay, so 3 quarters plus 2 quarters is equal to 5/4, so 5 quarters. Plus another 3 quarters is equal to 8/4, so 8 quarters. But we know that 8/4 is the same as 8 divided by 4, and we know that that is equal to 2. So now all we need to do is go 4 multiplied by 3 multiplied by a quarter, okay? And remember, the commutative law of multiplication says you can multiply in any order and you'll still get the same answer. So for me, I would say 4 multiplied by a quarter first. That gives me 1/2. And then 1 times 3 is equal to 3. Okay? You could convert all of them to fractions and then multiply them. So you'd have 4/1 times 3/1 times a quarter. Still going to get you the same answer of 3. You could say 3 times a quarter, and that's equal to 3 quarters. And then 4 multiplied by 3 quarters, that's also going to give you 3, okay? Right, your mental arithmetic questions are on the screen. There are 9 of them. Please work through them methodically. Again, write everything down. Make sure you write it down neatly and logically so it can make sense not only to yourself, but remember that there is going to be someone else marking your work during assessments or classwork and homework, and they also need to make sense of what you're writing down. Remember to check your work. We've spent a lot of time on checking strategies, and yeah, take your time. There's no rush. Remember, it's quality that we're looking for, and then press play to see how you guys get on. So what I decided to do today is actually turn this mental arithmetic into a number talk, including the mental arithmetic calculations. So we're just going to talk through some of the numbers and just make it a little bit more interactive. So 66,62, if I write that down, okay, what is that number composed of? It's 60, it's 6, it's 0,6, and it's 0,02. Okay, so we know that's 6 times 10. We know that that's 6 times 1. We know that that's 6 times 1/10. Okay, and we know that that is 2 times 1/100. Okay, we know that 7,08, okay, is consisted of 7 units. So that's going to be 7 multiplied by 1 equals 7. There's no tenths, so anything multiplied by 0 is equal to 0. Okay, and then the 8 is going to be 8 multiplied by 1 over 100. And that's going to be 0,08. Okay, so there I just thought we would add in a little bit of place value before we did the calculation. Now you know that when you add, you can simply add in the column method. Make sure that the numbers are in the correct place value columns, and then we just add normally. Remember to carry decimals line up, and you're left with an answer of 73,70. To check, I must subtract 7,08 from 73,70, and we should get our original amount, 66,62, and we do. So therefore we know that our original addition calculation must be correct. Okay, you can split up the numbers there, guys, if you would like. So what I mean by that is you can say 60 plus 7 equals 67, 6 plus nothing really equals 6. Then you can add the tenths, 0,6 plus 0 again, okay, is 0,6. And then you're going to have 0,02 plus 0,08. And then you need to add those together. That's going to give you 0,1. And then if you add all of those amounts together, 67 plus 6 is 73. And then you need to add the 0,6 and 0,1. And that's going to give you 0,7. So 73,70. So you should get to the exact same answer. 2, I've already expanded the numbers for you. Okay, so I've taken the 32 and I've just written it in expanded notation. So 30 plus 2 plus 0,8, which is 8 tenths, plus 0,001, and that 1 over there is 1 over 1,000, so 1,000th. And then 22,739, I've just written in expanded notation as a recap for you, and that's 20 plus 2 plus 0,7 plus 0,03, and then the 9,000ths is 0,009. Okay, so there again, just a little recap for you of how we compose and decompose the numbers. You can then go from this point and say 30 minus 22, and then 2 minus 0, and then the tenths minus each other, and the thousandths minus each other. I think that would create a lot of extra work for you. What I would suggest that you do is you just subtract it normally in a column method. I think that will probably be the most efficient way for you to do it, and it will also ensure the least amount of careless errors. Okay, so when we do subtract in a column method, we know that we need to borrow when our numbers are not big enough. Okay, so we have 11 minus 9 is equal to 2. We have 9 minus 3 is equal to 6. 7 minus 7 is 0. 2 minus 2 is 0. And 3 minus 2 is 1. Now remember the check strategy we've been talking about for a while. We now go the opposite way. And we take 2 and 9 and we add them together to get 11. So that's correct. 6 and 3, does it give me 9? It does, so that's correct. 0 and 7 gives me 7, correct. 0 and 2 gives me 2. And then 1 and 2 gives me 3. So all of those calculations work out. So happy days. We know that our calculation must be correct. I can put it away. I don't have to check it again. I can move on confidently knowing that I've got that question correct. Okay. Long multiplication question next. And that looks like 92 multiplied by 78. So as you guys know, there's quite a few different methods we can use here. Column method, doubling and halving, they're both even numbers, so that could work out for us. We could split them up. We could compensate. What I'm going to do today is I'm going to compensate, and let's see how that works out. So I'm going to say 92 multiplied by 80. So I've added an extra 2 groups of 92 onto the question. Then I'm going to say 92 multiplied by 8. Okay, and I know that 9 times 8 is 72. Okay, so that's going to be 720 because it's 90 times 8. And then 2 times 8 is 16. So 720 and 16 is 736. But I must remember the multiple of 10. So that's going to give me 7,360. Okay, 92 multiplied by 80. However, I gave the question an extra 2 groups of 92. 92 multiplied by 2 is 184. So I then need to say 7,360 minus 184. Okay, and that's going to look like this. And you should get a final answer of 7,176. But let's not just take that for granted. Let's have a look at another method and let's see if it works out. So let's try doubling and halving. So I'm going to halve 92, and that's going to give me 46. And I'm going to double 178, and that's going to give me 156. Okay, still both even. So let's halve again. 23 multiplied by 312. Okay, so that doesn't really make the question that much easier because I can't halve 23 again because that's going to give me a decimal. So doubling and halving perhaps doesn't work in this situation. You may absolutely do 23 times 112 and you're more than likely going to get the same answer, but that's perhaps one that hasn't worked in our favor this time. We know we have the column method to always fall back on. 2 times 8 16, 8 times 9 72, plus the 1 is 73. Remember the 0. 7 times 2 is 14, add the 1. And then 7 times 9 is 63, plus that 1 is 64. And then let's see if they add up to the same. 7176. Okay, both the same answer, so both must be correct. The other method that I'm just going to shoot through quickly is a kind of a split method. So I split 92 up into 90 and 2, and 70 and 8 into 70 and 8. Right, I then multiply them, and I can say 90 times 70. I know 9 times 7 is 63, and then there are 2 zeros in the question, so 2 zeros in the answer. 90 times 8 is 720. 70 times 2 and 8 times 2, and then if I add them together I'll get 6,440. I get 736, and then I need to add these two together, and if you add those two together you get 7176. Okay, so all three methods work out there. Doubling and halving perhaps was the only method that didn't make the calculation easier for us. But I just think it's a really cool tool to have to know how to use all the different methods, because one of them might be a lot easier than the other one. Okay, division next, and it's short division, so it's a little bit more straightforward. Okay, and that's going to be 1,918 divided by 7, short division because we're dividing by a single digit. 7 doesn't go into the 1, decimals must line up. 7 into 19 goes twice, left with 5, my apologies. 7 into 51 goes 7 times, and that's 7 times 7 is 49, so we're left with 2. And then 7 into 28 goes 4 times, and your answer is 0,274. Now to check that, 0,274 multiplied by 7. Okay, and we've spoken about the multiplication of decimals. You can take out this decimal by multiplying it by 1,000, and then you got 274 times 7. If you work that out, it's going to give you 1,918, but then obviously you must divide by that 1,000 at the end, and that will give you your 1,918. So I'm happy with that calculation. Question 5 is the subtraction of a mixed number and a fraction, and we know a mixed number is a whole number and a fraction combined. So our first step here is to convert this mixed fraction into an improper fraction, and we do that. We say the whole number 3 times the denominator. 3 times 3 is 9, plus the numerator is 11 over 3, minus 2 over 7. Yes, our lowest common denominator of 3 and 7 is 21. 3 goes into 21 7 times, so 7 times 11 is 77. 7 goes into 21 3 times, so 3 times 2 is 6. Okay, and now we're left with an answer of 71 over 21. And if you needed to convert that into a mixed number again, 21 goes into 71 3 times. Okay, so 21 times 3 is 63, and that leaves us with 8 over 21. Okay, great. Then we had the division of a decimal by multiple of 10, and it's 1,000. So 456,1 divided by 1,000. We know the number is going to get smaller by however many zeros there are in the number we're dividing by. So 3 zeros, it must get smaller by 3 places, and that's going to be your answer. Okay? We know that 4/5 divided by 6 can be written as 4/5 divided by 6 over 1. We know that the division sign must change to multiply, and that the fraction after the division sign gets inverted and becomes its reciprocal. And now we just multiply the numerators together. 4 times 1 is 4. Multiply the denominators together. 5 times 6 is 30. Okay, and then we can just simplify to 2 over 15. Just remember that if you want to miss out this step entirely, you could say 2 goes into 6 3 times and 2 goes into 4 twice. And then you've got 2 times 1 is 2, and 5 times 3 is 15. And there you avoid your simplifying process. Question 8 is multiplication of a fraction and a whole number. And if you just remember what I've just worked through with you, we could say 4 over 7 times 3 over 1. So we've got 2 fractions to work with. Multiply the numerators, multiply the denominator, you get 12 over 7. If you need to convert that into a mixed fraction, 7 goes into 12 once, and there's 5 over 7 left over. Okay? And then your last question is to find the percentage of an amount, and that's going to be 15% of 180. So I've always said to you guys again that there's a couple of ways of doing this, but for me the easiest way is to first find 10%, and I do that by dividing by 10. So that gives me 18. 180 divided by 10 is 18. If I know 10%, I can figure out 5% because it's simply half of 10%. So half of 18 is 9. I add them together, I have 15%. I add these together, I have 27. And my answer, 15% of 180, is indeed 27. Alternatively, you could turn them both into fractions, because we know that of is multiply when we come to fractions, and that's what your fraction calculation will look like. You know that 10 goes into 100 10 times, goes into 180 18 times. We can simplify it further to 2 goes into 10 5 times, 2 goes into 18 9 times. We could then simplify 5 over 15 to 3 multiplied by 9, because 9 over 1 is equal to 9, and there is your answer of 27 again. Okay, guys, I hope you guys work through those carefully, methodically. If you've made any mistakes, it's really important for you to identify your mistakes. Quite often I tell my students to actually write down the errors that they make, and the reason for that is because once you recognize the mistakes that you make, it's unlikely that you're going to make them again. But if you keep making the same mistake over and over again, that means you haven't recognized it, you haven't addressed it, and I would encourage you to do so, so that now that you move forward, you don't make those careless errors anymore. Okay, today we're going to look at ratio. That's our main theme for today's lesson. Now, a ratio compares the sizes of parts or quantities to each other. And for example, what is the ratio of red counters to blue counters? So if you have a look at that, red to blue, you know they're 9 red, they're 3 blue. And then we can simplify that ratio to 3:1. Now the way we simplify that is very similar to the way we simplify fractions, in that we look for the highest common factor that goes into both 9 and 3, and that is indeed 3. So both 9 and 3 can be divided by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So your simplified ratio of red to blue is 3:1. It's very important that the ratio is written in the order that they tell you about. So if they say the ratio of red counters to blue counters, then the red must come first and the blue must come second. Okay? And we read it for every 3 red counters, there's 1 blue counter. Okay? Now they've changed the order and they've said, what is the ratio of blue counters to red counters? And again, now you can see how the ratio actually changes, and it's now 1:3, whereas before, when red came first, it was 3:1. So just make sure you recognize the order that the ratio needs to be written in, and you recognize how and when you can simplify your ratios. Okay, so here we have 3 ratios. So what is the ratio of red counters to yellow counters to blue counters? So that's what we're looking for. Red is to yellow is to blue, written with those colons. Let's have a look. So there are 12 red, there are 4 yellow, there are 8 blue. You should be able to recognize that all 3 of those numbers are even, and to go one step further, you should recognize that all of those numbers are multiples of 4. So I should be able to divide 12, 4, and 8 by the number 4, and I can do that. So 12 divided by 4 is 3, 4 divided by 4 is 1, and 8 divided by 4 is 2. So my simplified ratio is 3:1:2, and you can see that is in the order of red counters to yellow counters to blue counters. Okay, and then you would read it, for every 3 red counters, there's 1 yellow counter and 2 blue counters. Okay, so I've touched on simplifying ratios already and how similar it is to simplifying fractions, and that we need to find the highest common factor. So if I've got 21:35, I need to recognize that 21 and 35 are in the 7 times table, and that the highest common factor of 21 and 35 is indeed 7. And we simplify it by saying 21 divided by 7 is 3, and 35 divided by 7 is 5. So our simplified ratio is 3:5. So for a 3-part ratio, all 3 numbers must be divided by the same highest common factor. So 6:12:9. The highest common factor that goes into 6, 12, and 9 is going to be 3. So 3 goes into 6 twice, into 12 4 times, and into 9 3 times. So our simplified ratio of 6:12:9 is 2:4:3. Okay? So then we move on to simplifying ratios with units. And it's really important that we convert units to be the same thing. Okay, so you cannot simplify, for example, you cannot simplify 90 cents and 3 rand, because one's in cents and one's in rand. You need to have them both in cents or both in rands. Now here you can put them both in cents, and then you're going to have 90 cents is to 300 cents. Okay, and if we do that, it looks like that on the screen. Now they're both in the same unit, cents, And now we can simplify and find, okay, what is the highest common factor of 90 and 300? So yes, you'd be right in saying that it's 30. Okay, and if we simplify 90s to 300, divide both of them by 30. 90 divided by 30 is 3. 300 divided by 30 is 10, and you get an answer of 3 is to 10. You could have kept it as rands, but then you would have had 0.9 rands and 3 rands. And I just think simplifying with decimals makes it a little bit more complicated. And if you've been watching these lessons, you'll know that I try to avoid all complicated calculations because I just think they result in careless errors. Okay, so if I gave you 3 numbers, and here you can see one's in meters, 0.6 meters, one's in centimeters, 30 centimeters, and one's in millimeters, 450 millimeters. There's no ways we can compare those 3 numbers as they are on the screen at the moment. So we need to convert them to the same units, and the easiest unit to convert them to is indeed centimeters. You could have gone millimeters, numbers would have been bigger, and just having bigger numbers by themselves can sometimes result in careless errors. You could have gone to meters, but as I said before, you would then be dealing with decimals, and for me that could result in avoidable errors. So to convert or simplify 60, 30, and 45, what number goes into 60, 30, and 45? And just like when we used fractions, you can simplify more than once. So if you didn't recognize that 15 was the highest common factor of all 3 numbers, 60, 30, and 45, you could have gone and divided first by 5, but then you would have had to simplify again and divide it by 3. But well done if you recognize that it was 15. 15 goes into 64 times, into 30 twice, and into 45 3 times. So therefore your simplified ratio of 60 is to 30 is to 45 is 4 is to 2 is to 3. So what that means is for every 4 centimeters of the 0.6 meters, there's 2 centimeters from the 30 centimeters, and then there's 3 centimeters from the 450 millimeters. Simplifying ratios containing decimals is another option, and it's something that we need to know how to do. But all we need to do there is then write the ratio in whole number form by multiplying both parts by 10. So in other words, get rid of the decimal. Okay? So if we multiply 0.8 by 10, we get 8. And if we multiply 2 by 10, we get 20. Now we've got 8 is to 20. It's going to be exactly the same ratio of 0.8 is to 2 because we've multiplied both numbers by 10. And now we can simplify 8 is to 20 by dividing by 4 because 4 is the highest common factor of 8 and 20. And our answer there is going to be 2 is to 5. So the simplified ratio of 0.8 is to 2 is 2 is to 5. Okay? Simplifying fractions or ratios containing fractions, and you would be 100% correct by saying, well, we need to convert the fraction to a whole number, and that is exactly what we need to do. So how do we convert 2/3 to a whole number? So ultimately we need to get rid of the denominator. And how do we get rid of the 3 from 2/3? We multiply by 3 so that those 2 3's can cancel. So we've got 2/3 is to 4. We multiply both numbers by 3 and that will cancel out the denominator of 3. And then we have 2 is to 12 because obviously 4 times 3 is 12. And then we can simplify that by dividing by 2, and the simplified ratio is 1 is to 6. Okay, so with fractions, we try to get rid of the denominator and turn it into a whole number. And with decimals, we're also getting rid of the decimal by multiplying by 10. Right, it's your turn. So I'd like you to simplify those 12 ratios on your screen. Remember what we've just spoken about. You may rewind and go through the last couple of slides just to recap and consolidate that information I spoke about. Give the 12 ratios on your screen a good shot. Press play to see how you guys get on. Okay, so your ratios on the screen. Looking at the first one, 8 is to 64. You you should recognize that both 8 and 64 are in the 8 times table, so both numbers can be divided by 8. So your simplified ratio there is 1 is to 8. Okay, 8 divided by 8 is 1, 64 divided by 8 is 8. 3 is to 24, again, recognize that both numbers are in the 3 times table, so 3 divided by 3 is 1, and 24 divided by 3 is 8, so we have 1 is to 8, again. 36 and 72, if you haven't recognized that 36 is half of 72, so we could also write it like that, okay, as a fraction, and actually simplify that fraction is equal to a half. Okay, so therefore that's going to be 1 is to 2. Now if you hadn't have recognized that, absolutely, you could have said, okay, 36 is to 32. Let's first divide by 2. You get 18 over 36. Let's divide by 2 again. You get 9 over 18. And I'm hopefully there when you get to 9 over 18, you can recognize that 9 is half of 18. Okay, so that's just to show you you can simplify more than once, just like fractions. 12 is to 48. Can you recognize that 12 and 48 are both in the 12 times table? 12 goes into 12 once and into 48 4 times. Okay, so that's your answer for the first 4. Okay, I'm just going to create a bit of space and get rid of this guy. And let's go to 5. These questions number 5 to 8. So here we've got 3 numbers in our ratio. You should recognize that all 3 numbers are in the 10 times table. So all 3 can be divided by 10. And you're left with 1 is to 2 is to 3. Half and a quarter. Okay, so remember with the half and a quarter, when we simplified fractions, we said we'd get rid of the denominator. So how do I get rid of the denominator in a half? So if I've got 1/2 is to 1/4, that's what we're looking at. I can multiply a half by 4, that's going to give me 2. And I can multiply a quarter by 4, and that's going to give me 1. Okay, so my simplified ratio there is 2 is to 1. Okay, let's just create some space quickly. So that's 2 is to 1. All right. 0,2 and 0,3, we said we were going to multiply both numbers by 10, and if I do that, I have 2 is to 3. Okay, so 0,2 times 10 is 2, 0,3 times 10 is 3, so that's my simplified ratio. 5 over 8 and 7 over 8, and you'll notice the difference between the question in number 6 and the question in number 8 is that in 6, the denominators are different, but in question number 8, the denominators are the same. So in question number 8, it's quite easy to turn the fractions into whole numbers because I just need to multiply each fraction by 8. So if I show you that 8 over 1 times 5 over 8, the 8's cancel out. So all I'm left with there is 5 now. Okay, and if I do the same to the other side, multiply by 8 over 1, the 8's cancel out. And all I'm left with there is 7. So my simplified ratio there is 5 is to 7. Okay. Right, let's get rid of this and go through the last 3. Okay, so I'm sorry, the last 4. Pull those over. There they are. Okay, so here it's all about the units that the amounts are in. So number 9, they're both in rands. So pretty straightforward, both in the 4 times table. So my ratio here is going to be 1 rand is to 3 rand. Okay. For question 10, I'm going to change the 1 meter into 100 centimeters. Okay, so now I've got them both in centimeters. Now I can compare. Both of them are even numbers. Both of them are in the 4 times table. So if I divide 12 by 4, I get 3. And if I divide 100 by 4, I get 25. So my simplified ratio there is 3 is to 25. In question 11, I'm going to convert both of them to grams. So 400 is to 1,000 grams. Okay, I can see straight away that both numbers are divisible by 100. Okay, so That's my simplified ratio, 4:10. And then I can go simplify again. They're both even, so they can both be divided by 2. So my simplified ratio there is 2:5. So for every 2 grams from the 400 grams, I would need 5 grams from the 1000 grams or 1 kilogram. And your last one, we're going to convert 1 minute to 60 seconds. Okay, you can see that 20 goes into both 20 and 60. So my simplified ratio there, 20 divided by 20 is 1, 60 divided by 20 is 3, and my simplified ratio is 1:3. Okay, guys, so that leads us on to our challenger for today. But while you're having a look at your screen and starting to calculate 24 using all the 4 numbers and a combination of the operational signs, please go back and have a look at simplifying ratios. Really important concept to understand, very similar to simplifying fractions. Have a look at the online activity that I've left on WorksheetCloud.com for you to do. There's also a memo that goes with it so you can consolidate the information that you've learned today. And a really handy tip is to actually do some of the online activity today and then maybe do some tomorrow, just so that you can double up on your consolidation and you can keep that information fresh in your mind. Grade 7s, thanks very much for joining me today. I appreciate your time. Remember the email address that's been on your screen throughout the whole lesson, grade7@worksheetcloud.com. Please feel free to use it. I look forward to seeing you guys next time. Keep safe and all the very best.